Good evening, everyone. I'm Deepa, your host for today. Welcome to today's webinar hosted by Technovus, an initiative of ARAI. Uh, we'll wait for a few more minutes for the participants to join. We would begin sharply at 4:05. Thank you for your patience. Good evening, everyone. I'm Deepa, your host for today. Once again, welcome to today's webinar hosted by Technovus, an initiative of ARAI. Before we go any further, kindly know that your active participation is really important throughout the session. You can post your queries in the chat box to avoid any disturbance during the session. Technos primarily is a collaborative and an innovative initiative undertaken by ARAI under the aegis of Ministry of Heavy Industry, Government of India. Its primary objective is to support startups, entrepreneurs, and developers in the innovation and development cycle by providing the necessary tools, resources, expertise, and mentorship which would be needed for them to uplevel their technology and the innovation to the stage that it can go further and tap the market. Technos focuses on mobility, especially on case that is connected and shared, affordable, safe, environment friendly, and energy independent solutions. Technos has different modules to help all stakeholders to take advantage of, such as tools, resources, expert connect, knowledge repository, and access to discussion forums. Please visit us on our e-portal at technovus.ariindia.com to know more. With this, I hand over. Uh, uh, with this, I'll come to the speaker's introduction. It gives me immense pleasure to introduce the speaker for today, Mr. Sarvesh Chakradev. We are really honored to have you with us today, sir. Mr. Sarvesh is a mechanical engineer with more than 8 years of experience in the field of product design and development. He is currently the team lead for R&D at Paradigm Electronics, based in Canada. With this, I hand over the session to you, Sarvesh, sir. Over to you.
Hey, thank you, Deepa. I'm trying to share my screen here. Do I have to do that again?
Yes, sir. Yes, sir. Because I started sharing.
I see. Okay, there you go.
Yeah, we can see your screen, sir.
Okay, awesome. Um, Hello, everyone. First of all, thank you, TechNovus and ARI, for this opportunity to share some of my learnings with all of you. So we are looking into additive manufacturing as a future of making today. Um, I'll just uh, I'll just dive right into it. Um, just need to change something here. Okay, so here's the outline for today. Just want to start with a quick introduction, and then give you like a part one is overview of just additive manufacturing. In part two, we'll dive deeper into some real world examples and applications. This will include, things which I have personally worked on my personal projects, as well as um, the 3D printing I've used at work in my professional life. And I also included part three, which is, how to get started. So, rather than just keep it very theoretical, we can talk about, okay, if you want to start 3D printing tomorrow, what are the steps and how you can get started there. I think Deepa already gave a great introduction, but here's me. My name is Sarvesh. Um, just to give you an idea, I've always been working since graduating with a master's degree. I've been working in the NPI NPD, so new product introduction, new product development field. So I've worked on a variety of different products and projects. Some of them are like audio. Currently, I'm at Paradigm Electronics, which is a loudspeaker manufacturer. So um, working on audio products. In the past, I've worked on different consumer goods, some medical device development, industrial equipment, and also some architectural installations. Um, so that's a little bit about me. Let's get right into it. I'm sure by this time everybody is, at least aware of or heard of what additive manufacturing is, or more popularly as it is called 3D printing. So if we are looking at like a classic textbook definition, it is the process of creating 3D objects by building them up layer by layer. And it was an innovation because it is fundamentally different from the traditional methods, which are subtractive. So you start with a chunk of aluminum or steel and then machine it or mill it. So that's how it is like fundamentally different. Um, and there are some advantages of trying to build files layer by layer. Um, Another good analogy to think of this is, think of building like a sand castle in the beach. So if you're out on the beach, what you do is you take your sand and then build towers out of it, or try to build a fort out of it. um, that would be like a 3D printing technology. Whereas imagine if you're doing some pottery work or building a fort during Diwali. That will be, you start with a mound of material and then carve out different things. So you make your gates and you make your walls. So that would be like a traditional manufacturing subtractive process. um, Another popular analogy is like building with Lego versus sculpting. So Lego is, you take a small brick and you keep adding on top of it. So the process itself, there are a few steps, and we can go deeper into this, and at the end we'll leave like 10 to 15 minutes for questions in case yeah, you guys have any. So step one is 3D modeling. So creating a 3D model using some kind of a CAD software, and we'll go deeper into this. Step two would be slicing the 3D model, so that it can talk to the 3D printer. The third step is actually uh, printing the thing you want to. And depending on the printer, depending on your part, there might be some post processing like cutting off the supports, or some cleanup or finishing. The most important step is also iterate, which I have highlighted in red, which is once you get your result, you evaluate and you reiterate and you build a better product or a better toy or whatever you have. Some key technologies for additive manufacturing. There's fuse deposition. That's one way. There's a photopolymerization process. That's a different technology. There's also powder base bed fusion, which is laser sintering, and we'll talk about that. And you do have like a variety of material choices. Most commonly, if you're a hobby level tinkerer, you will use PLA, which is biodegradable, widely available, and cheap. But you can also use functional plastics like ABS and nylon. There are high-end printers which will do steel, titanium, aluminum, and we'll talk about some applications. There's also some composites, ceramics, and biomaterials you can use. For example, I really recently found out that we can 3D print using bamboo, and that's a great application for my company, making loudspeakers, where we can, create concepts of speaker cabinets using bamboo. So fuse deposition modeling, right? The image or the video graphic should say it all, but this is one of the most common and accessible methods of 3D printing. All you have is like a XYZ gantry on which you install a hot end, is what it is called. All it does is you feed plastic into the hot end, um, which you can kind of see here. That's where the plastic filament goes in. This is the heating element. It heats up the plastic, melts it, and you start printing layer by layer from the bottom to the top. Um, there are a few popular printer companies like Prusa, Bamboo Labs, Ultimaker. There's a lot more. I just have listed a few which I have used and found quite good. Um, so that's the simplest, easiest type of printer you can have using fuse deposition modeling. There's a different technology called photopolymerization. So what actually happens in this kind of a printer is you have a bed which is full of liquid polymer. So that's actually your building material or building block, and you shoot a laser on the layer, um, and it will harden the liquid resin. And then once one layer is done, you move up, you build the second layer, you build the third layer on top of it. This kind of shows you like um, the process in a sped up way. On the left here is like a Formlabs printer. Uh, like you can see at the bottom, there is the tray with the photo resin on it. This black thing is the wiper. So after each layer, it will just move out and move the excess resin away. Um, the way Formlabs does it is instead of moving the bed, which is traditional, it moves it, actually it does move the beds, but the bed moves upside down. So it moves up. So it builds from the part is actually upside down. So this was the first layer and this was the last layer. And all these narrow vertical kind of webbed lines you see, that is support material, and we'll talk about that in a little bit, but that is something which will be needed to be taken off in post processing. These SLA DLP technology will give you very high detailed models. So think jewelry, dental application, very intricate prototypes. Then we come to the third type, which is the bed fusion, or SLS SLM, which is selective laser sintering. So instead of the um, vat of liquid resin, we have a powder. So the bed is actually full of powder material. Um, and then there is like a high powered laser which will selectively fuse the powder particles together. Um, so if you imagine like a cross section, it will solidify the cross section, and then again the idea is the same. The bed moves down or the laser moves up, and you keep building layer by layer. The advantages are, this process can be quite fast, and you can, with a big bed, you can fill it up with parts, and it doesn't take extra time to build one part versus two. There's a lot of cool applications for it. Popular printer companies are HP, Formlabs. There's a few others which are more commercial. I have not listed them here. Um, so that's that. So as I come to the towards the end of part one, I just want to take a minute to discuss some advantages. Um, the first one which I have listed here is just design freedom. So additive manufacturing removes many of the traditional design constraints. So it will allow engineers, designers to create complex geometries, intricate internal structures. Let's say you want some sort of a lattice structure for weight saving, and you can like consolidate multiple parts into a single component. Um, so for example, in my work, a lot of times I've embedded like small magnets into a 3D printed part, so so that it is magnetic without having to glue in the magnet later. Um, some other advantages with design freedom here is undercuts are allowed. So even if it's plastic, you can have undercuts. There is no need for drafts or tapers, things like that. The second one I have here is design democratization. So you don't actually have to be an engineer or designer, uh, you know study for a lot of years to build your designs. You can, any user anywhere can create what they like. It reduces the friction to go to market. You can test out your ideas, and if they're wrong, you can build it again. This is especially useful for startups. um, so it moves away design from like a specialized field in the hands of a few to and makes it available to everyone, which is a great thing. Third one is customization. So you can make one-off parts, customized products, which are not super expensive. This is game changing for areas like medical devices. You can design products for the patients. Implants, prosthetics, footwear, and we are seeing industry move in that direction. Um, Another advantage is it reduces the waste. So because it's not a subtractive method, which will generate like scrap material, additive manufacturing will build additively. So you will only use the materials that become the part of the final product. So imagine if you are working in aerospace and you have some titanium components. You don't want to start with a billet and machine away a lot of that because titanium is expensive. The last one is rapid prototyping, because so you can accelerate your product development cycle. Instead of having um, one concept a week, you can do 5 concepts a week, right? New designs can be printed, they can be tested quickly. We routinely print like a full speaker within like a day or two, depending on how big it is. So it reduces the time from concept to functional prototype from, instead of talking about months, so we can be weeks or a few days, depending on the complexity. So those are that's a quick introduction. I've deliberately kept it quick. Um, Most of this information I talked about, you can quite easily, look it up on the web, look it up on Chat GPT, and it should give you a good direction. Um, for part two, I want to focus on, real world applications and examples, which is a little bit harder for Chat GPT to do. So we have some human value here. Um, First off, the applications are wide, and they're growing every day. I have listed some sources at the bottom left here, so you can look up the videos later. um, One of the ones which was ripe for additive is aerospace, because um, their expensive parts failures are not tolerated, and it's a low volume industry. You're not making millions of Boeings every day, so the additive really shines here. Um, One example I have here is like Collins Aerospace, which manufactures turbine engine components. They've now moved to laser powder bed fusion technology, and they they traditionally used to make the engine components using machining plus brazing, and now they've moved to additive manufacturing. Um, if we go to automotive, you can obviously make jigs, fixtures, and we do that for our audio industry as well, and I will get into that in the future. Especially with automotive, the in the industrial design phase, the look and feel of the interiors, exteriors, that's like a really good area for having additive manufacturing just generate quick concepts. Um, the example here I have for Rolls-Royce is they're using 3D printed automotive metal parts, and the source is right here if you guys want to check out the article. There's a lot of medical and dental applications like I just spoke about. Um, s- I A few months ago I have flat feet, so I got 3D printed insoles as an orthotic thing, and it's great so far. I was they did measurements of my feet, and then they 3D printed an insole for me, which was fantastic. Um, which is kind of getting into consumer goods here, and there are examples of prefab houses construction. There's a 3D printing company called Icon. They do a lot of 3D printed construction projects. I've also left a blurb here for you. What will you use it for? Just so that you can think about your own applications. And I'm assuming we have a wide audience here, which will be a mix of students and professionals. So just to get your mind thinking on, where you can apply additive manufacturing for your personal use or work. So one of the examples I want to give here is a project I worked on back in 2018. So what you see here on the screen is a medical eye exam chair. Um, So we worked for a client called Harkstrite USA to develop the next generation of their medical chair and instrument stand. What you see on the right was the final approved concept. So after a lot of concept development, the the rendering on the right is what was actually approved by our client, Hux, right? Um, Once that concept was approved, um, um, my company, which was a design consulting firm, we were roped in to build this into an actual working functioning prototype and present it at the American Ophthalmology Show in Chicago. Um, and that's what you see on the left there. The image on the left, that's the actual functioning working prototype. And I want to cover a few areas where we utilized 3D printers. One, uh, the first one is this piece of plastic, which is the cover for chair. There's actually it's easier to see in the rendering here, but it's built into two pieces. Um, Traditionally, this would be made out of thermoformed plastic, you know, which was prohibitively expensive if we just wanted to build one unit. So there was no traditional way of building it. I mean, the other thing I can think of is trying to make it out of thermocol by trying to shape it into the right space, but again, it wouldn't be functional. So we actually made it using, so this is actually built using two pieces. So there's a cut right here. There's one part, the second part, and then we glued it together, and then we painted over it to get this part. It also has uh, snap design. So there's like a metal plate on the inside with holes in it, and this thing snaps in place. So it is actually very functional, and um, just playing with this design, you can translate it directly into production. So even though this is a functional prototype, it is ready for production. Um, the other parts where we utilize 3D printing were the remotes. So there is a hand remote here, there's a foot remote here, and the clamshell for that remote was 3D printed. All the buttons were 3D printed. We use different tricks like again, snaps, and also heat stick inserts. So you can get brass inserts which you can just heat up with a soldering gun and push it into the plastic, and then that gives you a very good fastening connection, so you can just screw it into something else. So as you can see, 3D printing can be great for one-off parts, where you're not where you're still gathering feedback, you're still in the design stage, you're not ready to make production parts. um, I think we got great feedback, and this show was a success. I hope you guys can appreciate how good looking the parts turned out. Like I just have both these pictures on the screen because even our team was surprised how close we got to the renders. Usually the complaint is, the renderings look beautiful and the real product doesn't match up. But I think here we were able to do a great job, and 3D printing or additive manufacturing helped us. Um, Here's another example I have. This is subwoofer part which uh, we recently released, and one of the challenges here was, while we were in pre-production, we wanted to make sure the pre-production closely follows actual production so that we can do time studies and things like that. So we designed there's a few jigs which are needed to put these parts together, and we designed these jigs using 3D printed parts. So one of the things I want to highlight here is this surround and dust cap material. Um, I'm not sure if this is clear on the screen, but this dust cap is actually not a flat piece, but a curved piece with the complex geometry. So there's like a curve in this direction, and there's also a curve in this direction and a boundary surface. Um, That dust cap needs to be glued onto this corrugated part we call the surround. Um, and we have a dust cap jig for it. So imagine um, it's kind of like a weight which you put on. Let me see, I can. So a weight which covers this entirely, and then you put extra additional weights on this, and then you glue these two parts together. So that's the idea. So if you can imagine the jig from a side view, it would look like a block. But if I look at the front face, it will have the negative of that dust cap feature. And that is a complex geometry. So to machine this would take a lot of time and efforts. And we didn't want to do that during the pre-production phase. So the easiest part thing was to 3D print this. And the accuracy of this was pretty good and it worked for pre-production. Um, so that I would call that a success. Eventually, we converted this into a jig made out of Delrin. So yeah. The third quick example is this is a sound bar with magnetic spacers, um, which are right here and here. So there are, if you can see the contrast, there is a plastic part here, which we call a spacer with a magnet in it. So the design challenge was how to, position this accurately. There are no locating features. We didn't want to drill into uh, the body of the soundbar because it would cause air leaks. We designed a jig which kind of looked like this. So it had like really thin fins at one end, and there were two holes here. So before the woofer is put in place, these holes can be utilized. Um, Additive manufacturing really shines here because to get a thin feature like this would be really hard using traditional manufacturing, and it would tend to break off. If we were doing traditionally, we would add some shims on the sides to position it in the y-axis, and then obviously this surface takes care of the x-axis for the if we are trying to position this spacer part. Um, but with the 3D printing, we were able to get like a very narrow uh, width of this fin here, which was like I think it was around 2 millimeters. So that was a great application. We also did a lot of prototyping before. I'm gonna erase everything here. Before approving this soundbar, we did a lot of, this is a aluminum extrusion with aluminum end caps. So the extrusion profile kind of looks like this. And there's like a wall hanging mechanism here. There's like some design lines around the edges. Sorry for my bad drawing here, but we did a lot of prototypes just to select the size of this soundbar, what the dimension should be, presented it to marketing management just to get their buy-in. So 3D printing helped us a lot, just gave them an idea of what the volumes were going to be like. um, we also extensively use 3D printing at my company for DFA, design for assembly. So 3D print parts together, even if they are not functional. Go down to the shop floor, try to assemble parts together, figure out faster ways of assembly. So there's a lot of value in using additive manufacturing for that purpose. Lastly, I have a slide here which gives you some design rules and tolerances, uh, which hopefully makes you think that 3D printing is great even in a professional setting and not just for hobbies. So I have the source from Formlabs here. You can check it out for more details. Some things I want to point your attention to is, so I've got FDM versus, oops, didn't mean to do that. So you have FDM, SLA, and SLS. FDM is obviously least accurate. So wall thickness is up to zero point 0.8, zero point 0.2 millimeters. Um, you can get like really nice like embossing details that gives you an idea of what the capabilities are. So 0.6 millimeter wide and 2 millimeter high. For FDM, zero point 0.1 millimeter embossed details, which is fantastic. And then for SLS, there are it's different for different direction, but it's still in the ballpark of like less than 0.5 millimeters. Um, as far as tolerances on the parts go, these are listed here, which is one of the reasons why we are able to use 3D printed parts for some of our production parts. So for small features up to 30 millimeters, it's plus minus 0.15%, or there's a lower limit of 0.02 millimeters, and that's just because of the nozzle thickness. Even for bigger features, it's still plus minus 0.3%, which is not bad at all, considering you can print your jig overnight instead of waiting for a day or a couple of days. So that was that. Just some real world applications where I professionally use 3D 3D printing for. Um, Now I want to give you a little bit more information on how to get started. And again, I'm going to keep this a little bit high level, just because you can again look this up on the internet and go deep into um, whatever area you have questions about. Um, I- I'm going to bring up this slide again, which talks about just step-by-step processes for how to 3D print parts, and then we can look at an example which I used, right? So this is a e-reader case or a Kindle case, which I designed and 3D printed. Um, so first step, as you can see on the left there, is 3D modeling it. And my neighbor here does like a lot of mandal designs. Uh, I've seen her notebooks, and some of the audience might be familiar with it. It's really hard work, trying to sketch that in black and white. But I was interested in the geometric patterns. Obviously, it is very trivial to do this in 3D CAD because you can just sketch something and pattern it and have all these dimensions. So it's really fast. So I kind of uh, modeled a case, and then I've got that design on the back of it. I used a Prusa 3D printer, um, and I got like a really nice light blue material, which you can see in the central picture, the printer going away, trying to print it. And then the last picture you see is of the case itself, and with the e-reader on it. I had to do some post processing. I had to clean off. There was support built into all of these, so it took me a while to clean this off, but the end result came out well. Going back one slide, what I'm not showing is the iterate portion of it, because it actually took me 2 tries to get the dimensions just right, and then to also get the pattern just right. So that is also very important, which not a lot of people talk about, but getting failed parts or getting parts which don't work is just part of the process, and that's how you can improve and be better. Every time I printed something, I think it was 2 or 3 prints, I made something better. This is an old picture. This was my first attempt, and these edges turned out really sharp. So the second attempt, I added like a small radius there. So there's small things like that, which, even if you don't think of in the first try, you can just do it again. Just to let you know, this took me around 4 to 5 hours to print, and the Prusa is not like the fastest printer on the block. Some of the other things I've used personally are cell phone cases, cell phone holders, toys, some bicycle parts, including like washers. Uh, we have a dishwasher which had a sensor failure because the sensor mounting bracket broke. So I just measured it, 3D printed it, mounted it back, and it's been working great for the last 1.5 years. So I'm going to call it that a win. Um, so 3D modeling, if you're not aware, uh, there are a few commercial modeling softwares, SolidWorks, Katia. There's a lot, and there's a lot of new ones coming in. There are, if you're not a professional, if you're a professional, you probably have access to one of these at work. If not, you can always request a trial just to get a feel of it. If you're not a professional working in a big company, you can still use some free freemium modeling softwares like Tinkercad and SketchUp. Those are free to use, I believe. If you're working on in a smaller company, you can still consider getting Autodesk Fusion products for they have subscription based products which are getting cheaper by the day. I've listed some YouTube resources if you want to get started with 3D modeling. And GrabCAD is a fantastic resource to actually get 3D models. So in case you want to just directly start printing, GrabCAD is an open source community where um, people will upload models for free. Sometimes they're also paid. Um, so that's one good resource. Deepa, how are we doing on time here? I see it's already 7:12.
Uh, yes, we do have three questions for now, so maybe 5 minutes more
Okay,
for the presentation.
okay, thank you. So I'm going to skip over the slicing part. Actually, I can just go over it quickly. So that's just an example of a slicer, and you can use a slicing software to import your 3D model, control your layer height, speed, infill, and support structures. There are and then design your parts. The green things you see here are support structures, and the orange one is the part, obviously, that's a Groot. um, so some considerations while you are trying to figure out which 3D printer you want to buy, which I would encourage you to. If you have the resources, uh, try to lobby for one at your work, or get 4 friends and buy it with friends. Here I've listed some configurations, like print quality, how fast you want your prints, what's the resolution you want, what's the application for it. Build volume is a big one. You can get small printers which are 15 centimeters by 15 centimeters by 15 centimeters, and you can get like the large commercial ones. So there's a lot of options. Ease of use is one, assembly, leveling, calibration, all of this comes with any printer you buy. Related is reliability, maintenance. So think about how much you will also spend in spare parts, nozzles, look up reviews, look up other people's experiences. There is a wide open source community where people will share their experiences. This price, value, safety. Mostly if you're a hobby level printer, you will use a PLA material, which is fine. But if you want ABS, nylon, you probably want some ventilation just for safety. And obviously look at reviews, recommendations. One blurb here is I want to shout out to my uh, seniors in college who started robo.in. I was pleasantly surprised to see they're also selling 3D printers now. So this is something I looked up yesterday, but Bamboo Labs A1 mini printer, that's available for 17,000 rupees. So even if you are thinking of it as a personal device, consumption device, that's not a bad value. Um, and there are other hobbies brands, commercial brands. I'm not endorsing any of these brands. These are just products which I've used or do use for work, and I've checked that all of these do have Indian distributors, so it should be possible to purchase these. And I think that's it. So we have 15 minutes for Q&A. I am putting in the QR code for, if you want the slide deck on the right, just scan it. You can get a PDF copy of this presentation. And on the left is my LinkedIn in case you want to connect, if you have any questions or just want to make a professional connection. Um, there was not a lot of interaction today, but thank you, everyone. And Deepa, you can open it up for the questions.
Yeah, thank you. Thank you so much, Mr. Sarvesh, for such an informative session. The forum is now open for Q&A. Please post your queries with respect to the webinar in the chat box, and we will address to them with the expert's permission, of course, and the time availability now. In case your queries with respect to the webinar are not addressed, you could always write to us to info@technovus.ariindia.com, and we will get back to you with the expert's answer. So, Mr. Sarvesh, we have three questions to begin with. As the other participants start putting their questions, I think we could just begin with these. The first question is from Abhay Gupta. He asks, what are the challenges in chair 3D printing? How to tackle them? Can we use it for automotive chair manufacturing? Is it cost effective?
So, thank you for your question, first of all. Um, as far as the challenges with the uh, prints we did there, one of the big ones was just to get the finish right. So we did a lot of tinkering on how to, like I mentioned before, we had to glue the two parts together and then prime it, paint it. So that took a lot of figuring out. So that was one of the challenge. Um, and yes, you can use the parts for um, sorry, Deepa, can you repeat the question? What was the application? Automotive seating?
Yeah, so can we use it for automotive chair manufacturing, and is it also cost effective?
So I wouldn't say it is cost effective in terms of building it for the masses, because you're going to if you're working at let's say Tata or any manufacturing company, you're probably making lakhs of these cars, right? So it will not make sense, especially for a car seat part which is going to be quite big. And if you're making hundreds of thousands of those parts, you would have to do cost analysis, though it would really depend on the part. But if you're just talking about just uh, plastic covers, like large plastic covers, I think it's going to be hard to justify the cost. But without knowing more, I wouldn't be able to give like a yes or no answer. So you would have to do a cost analysis.
All right. The next question is from Akshay. He is asking how to ensure finished product in 3D printing with less efforts in after finishing treatment. So I guess he's meaning that once the finishing treatments are done, how
Mhm.
do we ensure that the efforts put in for the finished product is less?
I see. Um, One thing is, it depends on the type of technology which you're using. So if you're using a FDM printer, the fuse deposition modeling, you will get some stair-stepping errors. The parts, will not you will not be able to build really intricate parts. But you can get really good resolution if you're using SLA, SLS printers. Um, a few of these printers also come with a dissolvable support. So taking off support and finishing is easier. Um, and again, I think you have to experiment. One of the big things is um, the orientation of the part. Uh, which what is your A surface? What surface is important for you, and can you keep that away from support material? And can you reorient your part even if it takes more time, so that your the geometry which is important for you visually is preserved. Um, I hope that answers the question. If there is a follow-up, please do post in the chat.
Yeah, Minal is asking, can you please mention future scope of 3D printing in automotive industry?
Um, that's kind of hard for me to answer because I don't really work in the automotive industry. But I see a lot of value for 3D printing, especially in the initial design, product development um, phase. So whenever you are working on concepts, um, it is less expensive to make mistakes in the concept stage rather than go all the way to production and find out there is something which you don't like or parts that don't fit. And that's where 3D printing comes in, where you can, quickly reiterate and solve your problems right in the initial phases.
All right. Sanjeev is asking, can you please elaborate more on how you embedded the magnet and the 3D printed? Uh, I think
Um,
he's left
sh-
it hanging. Yeah, but I get you
sure.
get the point.
I can try to sketch something, and you can probably find designs online, but just try to sketch something here. So if I draw a cross section, that's a bad cross section. Where is my eraser? Erase all. So let's say I have a cube or a cuboid like that. I was able to embed the magnet like right in the center of it. And the way I did it was when I'm printing layer by layer, right? Let's say I'm going to a cross section now. I built like a small pocket here. I started the printer. It went halfway. As soon as it reached this layer, I hit pause. I put in my magnet here, and then I told the printer to keep going. So it kept going and built the rest of the layers around it. And I had built like another pocket here, so um, it wouldn't interfere with the magnet there. One of the tricks was to also tape the magnet in place, because otherwise it will jump off and hit the nozzle. So hope that answers the question.
Okay, and for now, the last question. Uh, Participants, if you have any more queries, please feel free to post your questions in the chat box or the Q&A section. We still have time. We could address to them. Yeah. So Avinash is asking, can you please comment on time required for 3D printed part when compared to conventional method?
Um, Generally, I would say, at least for plastic parts, your 3D printers will be faster. Um, Having said that, you know, the time to print varies widely. So this e-reader case I printed, if it took me like, let's say, 3 to 4 hours on the Prusa, the bamboo printer which we recently bought for work is 3 to 4 times faster. So just because it has faster servo motors and better software, uh, it can literally print anything we have on the Prusa. It will print it 3 to 4 times faster. So it really depends. And again, this is FDM technology. If you go to the photopolymer SLA style parts, those can be even faster. So hope that answers your question. I didn't really answer your question, but I think the answer is it depends. And once you put your part in the slicer, it will give you like an estimated time how much it's going to take.
Yeah, so that was the last question that was asked. I believe we have covered every single question that was asked, and we still have 5 more minutes. So if you would like to add anything, sir, uh, say the slicing part you had skimmed through. So if you wanna uh, come back to it, we could. Else, we could end the session.
Sure. I mean, I think I kind
You
of
did
went over
cover
it.
it.
Yeah,
Yes.
so yeah, I mean, one thing I want to encourage everybody here is, the slide I had here, which talks about real world applications. What I want you guys to focus on is you, like what will you use it for and where do you see value? And I think the best way to learn is by doing. So I would encourage you to, actually try to print parts, think of problem solving where you could use additive manufacturing just to get started, and buy a printer, get your friends to buy a printer, get your workplace to buy a 3D printer for you, and see what it unlocks for you guys. So that's all I had.
Thank you. Thank you so much for your valuable information, sir. Um, in case participants you are not comfortable posting your queries here right now, you could also mail us, like I already mentioned, info@technos.araindia.com. We will forward the query to the expert and we'll get back to you with the expert's answer. And further, if you would want an one-on-one interaction, if the expert feels okay with your query, we would get you in touch with him as well. So that is for your information, participants. Thank
Yes,
you
thank
once
you.
again, Mr. Sarvesh, for sharing
Thank you.
your insights. It was all about providing our members with relevant resources that will aid us all in ensuring that every potential becomes a reality. On behalf of Technos and ARAI, we thank you all for joining us today. We hope you all found this information and dialogue valuable. You can all make a difference by synergizing technology and innovation. Goodbye and have a wonderful day.
Thank you, Deepa. Thank you, everybody. Thank you for your time.
Thank you, sir.
It was fantastic. Bye.
Bye bye. Good day.